Hello students, in this session we will going to discuss Inorder tree traversal, and this is the function for the Inorder tree traversal. So in Inorder function, so we are passing a root node. Okay, so the logic of this function is what? First we will check the root node is null or not. If root node is null, then if root node is not equal to null, then these set of statements will be executed. So it is the first statement, in order of root left link. So here the first statement is what? In order function recursively it calls itself, okay, and then display the root node, that is the value of the root node, and again the in order function it calls itself recursively. So I mean to say, in order to process the in order function, so in order function it is calling itself recursively twice. So one is for the left link and one is for the right link. And now this is the tree where we can see how the in order function will process. So when I say root node, so what we should pass to the in order function? Root node. And when I say this is a tree, so this is the root node, and this is the left subtree for the root node, and this is the right subtree for the root node. Okay, so now when I say the L link for root node 100 is what? This one, and R link for the root node 100 is what? So this one. Okay, now when 90 is a root node, the L link for the 90 is what? 50. The R link for the 90 is what? It is 95. Same for 200. If 200 is a root node, then the left link for the 200 is 150 and the right link for 200 is 300. So this is what a left link and right link in the in order. So what is this left link, L link and R link means? So R link it points to the left child of the root node, and R link it points to the right child of the root node. Okay. Now we will see the analysis of the in order function. I will take the same example, tree example. So when I pass this 100, now how the function can be constructed? See, in order of root node is what? 100. So firstly the root node must be passed, that is for the one time. So when I pass this in order of 100, so this will be executed. So here the root node is not equal to null. Root node is what? 100. It is not null. So these set of statements will be executed. So in order of 90, again here as soon as the in order of 100 it starts executing, so in order of 90 will be called. I mean to say, in order function it calls recursively by taking left link. Left link means 90 is a left link to the 100. So that is in order of 90. Now the function in order of 90 will be processed. So the control is given to here. So in order of 90. In order of 90, again the root node is not equal to null. Root node is what? 90. So these set of statements will be executed. So here again this function it calls recursively by taking the 50, which is a left link of 90. So in order of 50. Again, so in order of 50, so again the control is given to this function. Again the root node is 50 now. The root node is 50 now. So 50 root node is not equal to null. So these set of statements are executed. So in order of, so see here in the tree 50 doesn't have the left child or the right child. Now what is the value of this left child? R link and L link and R link, it is null. In order of null. When root node is null, then which statement will be executed? So this statement will be executed. So which is a 50 will be displayed first. Then the next statement is in order of R link. R link is what? There is no left child to the 50, so it is null. So when I say null, so what happens? The control is given back to this function, not to this function, to this function. Here immediately following this statement. So cout 90. So 90 will be displayed. After displaying the 90, again in this function two statements are executed. Now the third statement is in order of 95. 95 is what? This is a node which is considered as a root node. Now it should execute recursively again. So the control is given to here in order of 95. In order of 95 means here. So here for the 95 there are no left child or the right child. Again in order of null, this will not execute recursively, so this statement will be executed, that is 95 will be displayed, and after this statement must be executed in order of null. There is no right child again, so the control is given back to this particular function, that is the first function. Okay, so when I give a control here, what happens? Cout 100, so this will be executed, 100 is displayed on the screen. Okay, now after this statement, this statement must be processed, that is in order of 200. Now the root node is what? 200 is having two children, that is the left child 150 and the right child is 300. Again the in order function must be processed for 2 times, that is in order of 200 the control is given to this function. Here in order of 150, again the control is given to in order of 150. See here, in 150, for 150 there are no left child and there are no right child, so it is null, so it will display 150 here on the display screen, and then in order of null, no right child, so the control is given back to cout statement for this function. So here cout 200 will be displayed on the screen. Again this statement must be executed after cout statement. So in order of 300 means, so this must be again recursively called by passing 300. So the control is given here. So in order of 300 the control is here now. So in order of 300 means it doesn't have a left child or the right child, so it is null. So cout 300. So after displaying the cout, the control again it is given back to here. Again once it receives a control, this function, again the control here it is given to this function. This is the first function, and for this function this is the link, and for this statement, so this is the link. So this is how the Inorder function it calls recursively twice to process the Inorder tree traversal for the tree.